All right, here we go. We're going to look at LiDAR again, and this is pretty exciting. So let me start a new file so that you can see what I went through. Just get rid of that and move this over. This is a new file. We, in class last Thursday, we used the points.laz for Pasco County that I had downloaded from Open Topography. So I'm opening up that in my browser here on the D drive and just dragging it over onto the screen. You can see if we go to the web and go to Quick Map Services and bring in Google Hybrid, you can see that we are in fact in Pasco County, and it lays over fine, at least on this machine at this moment. So there it is, Rosebud Continuum. But what's fun is that with this, if we go to the normal 3D viewer, and I'm going to save this actually. Every time you do something, you should save. Pasco Point Cloud. Okay, so I'm going to overwrite the old one. But so you go to the view and go to 3D map views and do a new map view. And now press that middle mouse button and drag it, and you'll see that it is 3D data in there. It looks ugly as sin, and that has to do with the classification. And I had this thing open, you may not. So you'll want to go to Layer and go to, I want to go to View Layer. No, sorry, go to View and then Panels and then Layers Styling. That's what it is. Panels, Layer Styling. And that should give you something here. It's down here, and you say Processing Toolbox. Now Layer Styling. So don't get lost. It now appears there. There's a classification, and it looks like if we look at our 3D map that all that gray is points for trees. It's unclassified. So if we want to make these look like trees, that is up to us to do that. And maybe it's not dark enough. Okay. And now when you look at it, it looks a little bit better. The buildings are red and they don't need to be red. And somehow, there we go. So the buildings are red, and the buildings, if anything, should be the ones that are more gray in here. Though we don't like gray buildings, but that will help a little bit. And then the water, I think that's a too light a color, so let's go for that for the water, or maybe that. Water, something more interesting. And there's these other bands, and I don't know. Road surface black is fine, I suppose, if it's asphalt. Number 23, number 31, whatever those are. The ground is a little bit, I don't care for the color of the ground. I think the ground a little darker. And then we can set this band to a greenish color also, because if you look here, they look like rows of trees. So now we have a better map, but it still doesn't look very good. And so what we have to do is go to this little wrench here and go to the terrain. You can do terrain shading, but that doesn't really fix it either. Go to Effects and do Show iDome Lighting. That gives it a more cartoony look. So that's a little bit better, looking at that. And then we can also look at, under, not advanced, but I think that's fine for this. Maybe the lighting should be turned around a little bit. But what we want to do with this is now go into the styling and go to the 3D box here and go to render as surface, triangulate. And you'll see now that it is triangulating, but the lighting is really, really bad. So maybe we need to change the direction of the lights again and see what that comes to. Maybe we need to make the intensity a little higher now. Let's try 5 for the intensity. It's too intense actually. So it's not good. So let's go to 2. So I was getting better results before, and I'm not exactly sure why. Single color, attribute, classification. Let's maybe it's something to do with the colors that I did. We'll try this again and remove this. And let's do it again. Actually, let's turn off the layer of the Google Hybrid, because that may be affecting it. And let's just drag it in again. And let's go and make the water, this for the trees. Go like this. And we'll do the buildings as a grayish color. And we will do the 31 as well. And then let's look at here.
Yeah.
And I'll get rid of the other, this one here, and do a new one. So 3D map views, go there, and there's the layer. And then we were going into here, and we said to bring it to show iDome lighting, and that gave us a more interesting look. All the buildings that are there. Don't know what these bands are, but then we dock this, bring this over here and dock it. Okay, it's docked over here. I wanted to dock it down, I think up here. Yeah, there we go. Okay. And we said we wanted to go here and say render as a surface triangular. That's much better. Yeah. So that triangulates it and makes a mesh out of it, but there's no way to export that mesh, it seems. It would be nice if we could go to export and save it as a 3D scene and let it do the export, but it didn't export the points. So can't export this to Blender yet until we learn how to do it, but it's, and there's some discrepancies here with that. Point sizes, and you can also do the render as surface like this, and that is in the classification, and then in the 3D render as a surface, but the points get to be kind of crazy in there. So all of that is interesting. That's one thing that you can do with this. I'm going to see what happens now with the QGIS to 3D, but it doesn't seem to do anything. So this one does not know what to do without a DEM. It needs a DEM in order to be able to see something, it appears. Add flat, add point cloud layer. But we don't have a point cloud layer, or do we? See, Pasco point cloud, shapefile exports. So yeah, we don't really have a, it's supposed to be a supported file URL. So we don't have that yet, but apparently this one can do it. And that's what we're going to be looking at here. There's a tutorial, which I'm watching, and it says that we need to get...
Choose Manage and Install Plugins.
A plugin called Profile.
Click the Installed button on the left side of the window to view the plugins that are already installed. Choose the All tab and search for Profile tool.
This is coming from the QGIS lesson on importing and visualizing 3D point cloud data with QGIS. So, thank you for the tea. So, yet another plugin to work on. And that other plugin is going to plugins, manage and install. And we're on all and say profile. And the profile tool is here. Plots terrain profile. Supports multiple lines, graph export. Supports 3D polyline export. I think that's the one that they're asking us to do. Let's see.
Take a moment to read the description of the tool and take note of the latest update. If your results show a checkbox next to the tool, the plugin has already been installed. Click Install Plugin.
So let's go ahead and click Install Plugin. And then get another plugin. Okay, what is Profile Export? To XML. Okay, we don't need that. Alright, so we have that. Now, where is it?
A notification should appear at the top of the window stating it was successful, and the option to uninstall the plugin will also appear. Close the window. We will import one of the last tiles with the Data Source Manager. Open the Data Source Manager, and in the left column choose Point Cloud. Since this data is saved to our local machine, ensure the source type is set to File. To set our data source, click the ellipses button to browse to our source file location and open the last folder. Select LD 3174.
Well, that's one that they're talking about. So for us, I suppose, and what do I have here? What is this? This is an older one. There we go. Okay. So they're suggesting we go here to the Open Data Source Manager and File and go to Point Cloud. And then I had this point cloud from Pasco called Points. So if I add this, I can't imagine that it's going to do anything different than what I already had. Like I have. So yeah, I already had that. And I had manipulated it. That's the unclassified one that I just brought in. So that didn't do much of anything. All right, great. What then?
Or 1380. The project Garden, resulting in the low point noise classification. Unselect ground and turn on low point noise. This classification is unknown, but since many of these points surround vertical rock outcrops, It can be assumed that these laser pulses are multipath returns. They bounced between objects and took longer to return to the sensor than the surrounding unclassified points, resulting in the low point noise classification. Turn off the unclassified and low point noise and select high noise. File, Properties, or by double-clicking the layer. Explore the different tabs on the left. Information will present an overview of the layer, including coordinate reference system, metadata, and the attributes within this dataset. Within the metadata section, classification, click the layer and choose Filter. In the Fields window, double-click Z to start a script expression, followed by the less than or equal to operator, and put 6,400 as your limit. Click Test to see the points that fit your expression, and if successful, a pop-up should appear. Click OK and keep the query builder open. There are numerous ground and unclassified points on the outer extent. Press 504 feet.
So this is interesting.
Hit the gaps between data points. The mouse wheel, or by toggling on-screen navigation, zoom out until your data appears. Hold down the Shift key and click and hold down the left mouse button in the middle of the configuration menu and the 2D and 3D maps to enable the current minimum and maximum Z value. Then manually change the minimum Z value. Here we switch the mode for symbology. Move around the 3D. Once you change in feet, data in 2D and 3D. As QGIS tool.
So that's interesting.
Open this feature by going to View and selecting Elevation Profile.
Elevation Profile A. So if we go to here, and we go View Elevation Profile, and we see an elevation profile. Doesn't seem to do much of anything because there doesn't seem to be much elevation. -5 minutes. Why is there no elevation? Why is that? Nothing. No elevation profile.
Select Capture Curve and use the crosshair to draw your line of interest. Single-click the left mouse button to start your profile, and left-click to insert vertices along your path and chain.
Oh, interesting. Okay, so if we were, if this one's put on this one, we're going to go to Capture Curve and then say, well, what is the elevation distance when you come from the road to Rosebud? So when you come and you go there, 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 and then when you right click, yeah, so it does go down. Appears. Interesting. So that's the ground. And then as you move around, you can see the path, and you can see that you're basically going down into the lake. And as you get here, there's buildings. So if we did a different thing, if we came from the road to here, and then went across to the building, you go across the house, and then down into the lake, right into the lake. We have a different profile. And as we move our way across it, you can see that when we get to the house, there are these data points that are much higher right here. Hard to tell, but they're not really showing up. This one's for teeny points, but it is neat. You can see you'd have an elevation, and if there was mountains, you would know what you're doing with the mountains. So that's pretty cool, and you can play the path. Yes. Come back here and play, and what does this do? Who knows? So you go, click it, goes down into the lake, and there's all this scatter of trees and stuff like that. What is this one here? Capture a curve from a feature. Identify features. I don't know what that does yet. But yeah, pretty cool. All right, elevation profiles. Nice to know. That's cool. All right. So that was a great learning thing for us. And now there's another one that I was doing that was here.
Here, you'll click that, you'll download the PDAL pipeline. It's going to give you a JSON file. And I've talked about this in previous videos, so you can go check those out. And it's going to look like this.
So I wanted to get a 3-dep file. Stream point clouds from the 3-dep online repository. So you don't have to download the underlying data. So let's see what that involves. So there's 3-dep LiDAR Explorer.
Yeah.
Hold on. So apparently there's a new training video on using LiDAR Explorer. Go to video. But I want to go to LiDAR Explorer. So 3D elevation program. Where is it? 3DB. Doesn't help me. I wonder if it's under Web Tools. LiDAR Explorer. Okay, so go to LiDAR Explorer. Gulf of America. My God, Mount McKinley.
Did they change it?
Yeah, QGIS. How ridiculous. Morons. Okay, show where LiDAR is available. And so if we come to Florida, then isn't that interesting? Tampa doesn't have it. Tampa has DEM. LiDAR. Tampa doesn't have good LiDAR. Control key down. Pasco County. Downloadable DEMS LiDAR with.
Yeah, they changed it. Even on Google, it says Gulf of
Maybe I don't want to use
It's not
this.
Gulf of
What I
Mexico.
do want to use. I guess that means it's not really high resolution, maybe, because there is something there. So here's Land O'Lakes, Hadget Lake. 54 is here. I want to control and do this.
Yeah, they did that.
Land O'Lakes Boulevard. I'm going to start like this and find the actual lake. There's Bell Lake, Dupree Lakes, and Aaron Cutoff, East Lake, Black Lake. There it is, Hale Road. So we're this one here. This is the one we're looking at. So we want to just get this here, and then there is some LiDAR available. Bathy LiDAR. I guess then all you do is you go to LiDAR processing, and you process in cloud or save PDAL. Let's find out. There's the output projection 3857. Output format LAZ. And then what do we do?
Down here, you'll click that, you'll download the PDAL pipeline. It's going to give you a JSON file. And I've talked about this in previous videos, so you can go check those out. And it's going to look like this. You're going to have a one-line JSON file that gives you pipeline type readers.ept and this file name, which is a URL to a JSON file that specifies the EPT. Okay, so I am just going to copy this right here. I'm going to copy that, Control C. Now I'm going to go to QGIS.
Okay, so they're saying to go go to save QGIS pipeline, open it up. Visual Studio. That's not what I wanted. Why is that happening? Maybe I'm looking at the wrong thing. Change the max filter by returns, and it's taking its sweet time doing this. So what did he do that I'm not doing?
Like this. You're gonna have a click that, you'll download the PDAL pipeline. It's going to give you a failed network error here. What will happen is when you get it, you'll see a LiDAR processing or explore LiDAR data button down here. You'll click that, you'll download the PDAL pipeline.
I think there's a button down here that he's covering up with his face. So, there it is. It came in. That's what he's talking about, the pipeline up to the JSON. So he's saying
it's going to give you a JSON file. And I've talked about this in previous videos, so you can go check those out. And it's going to look like this. You're going to have a one-line JSON file that gives you pipeline type readers.ept and this file name, which is a URL to a JSON file that specifies the EPT. Okay, so I am just going to copy this right here. I'm going to copy that, Control C. Now I'm going to go to.
So that's what we want. This, not the quote. So this one here is the JSON file. Right click and copy that. I hope I got it. And to make sure I got it, I can always go into a new URL and see what I got. Yeah, I got it. And that's all that information in there. All right. So I have that copied into the buffer. What next? Open up QGIS.
QGIS. Okay, and here I am in QGIS, and I'm going to add a point cloud. So I can go to Layer Data Source Manager. I'm going to go to Point Cloud, and I'm just going to select Protocol HTTP. I'm going to paste in my URI, which is that URL address, and I am going to click Add. And then I can close this, and you can see that my point cloud is loading. This is going to take just a minute, and now we can see that we have that whole point cloud for quite a large area, and right now it's showing the classifications.
That's pretty cool. So apparently this live streaming is not something that you can do. Close the elevation profile. Let me make sure how I got that, by the way. How did I do it? How did I get the elevation profile? View, and then elevation profile. So that's how I got the elevation profile, which is cool. But anyway, I'll turn off mine, the one that I got from the Open Topography, and let's see what he's talking about. We're going to add a layer, and we're going to add a point cloud layer. Where's the point cloud layer? No? Create layer? New spatial? No, that's not it. Data source manager, sure. Use that point cloud. And then here, this time, go to that and put in the URL and say add. And then close. And here it goes. And then here it is. Oh, look at that. It's the same, but this is the point cloud that I pulled off, and it's actually pulling off in real time. So as I zoom out, I can get more and more and more because it's streaming from online. That's pretty cool, because my other one that is resident on my machine, let me put this under it. Let's bring this way down to the bottom. Okay. Right, there's that, and then there's my other one, which I can put on top. So you can see mine, and there is theirs. And that means that when we turn off mine and look at theirs, created, never classified, unclassified, I suppose that's the, once again, that's the unclassified is the trees. Draw that. That when we do go to the 3D view and we go to our 3D map was created using a layer that is not checked. I guess if I uncheck this, that goes away. So, yeah, so it is actually streaming it now. And that means that as we zoom in and out, we'll get a 3D view that is ever larger or smaller. Is that correct?
Okay.
And let's go and make sure we have the iDome lighting is already on. But I can make a new view. So let's take this out of it. Let's manage the views and let's get rid of this map view.
Yes, can you turn the light off and
Which one?
this big light?
And so when we now go to make a new view, and we manage the 3D network view, that data starts to come in, and once again, it doesn't look all that good because we have not told it to show the iDome lighting. We kept the iDome lighting. There's a lot of extraneous data in there. But what you're having go on is you can go out and out and out until you get to the entire tile that I've gotten, as opposed to zooming in. So this is live streaming data. And I guess when we go to symbol, if we render this a surface, it'll take longer. And maybe we just crash the system. But yeah, there we go. So now we're getting those polygons in there. But these really massive triangles there. That's really funny. Okay, so that's kind of cool. And you say skip triangles taller than, let's say skip triangles taller than 10, see what that does. Yeah, it says a little bit better. Skip those triangles when you're making a triangularized mesh. But that's pretty cool. I can do further classification. That's so this is what happens when you use the live streaming data as opposed to our own little section over here. And when we do that, and we look at the map view, I mean, we can focus in on our own data within that whole cloud. Make a new view. Let's get rid of this one. Let's make it based on that view of our lake here. And so if we wanted to measure this, the elevation, then we would go again to view and elevation profile. We would click here and draw our paths. As you come along here and onto the property and on and across the lake and down, we could see what that path would do for water if we wanted to look at water. And so render, yeah, so there it is. You can see that there's the lake, and then we go up and then it really dips down here. So this is where that drainage was. And that's why one has to be very careful about, see where this retention pond is. That retention pond is the deepest part over there, which is cool because if you do this again, if we say, well, all right, so if you come across the lake, and go to this retention pond, and then this retention pond, and then through this retention pond, and then down to these retention ponds, and up here, you can see how planners would make this work. And so this is a fairly shallow lake, it's 10 feet, and then up here, we go up a sort of hill, and then down into this retention pond, and then down into this retention pond here, and then it goes deep, dips in here, up, elevated, down, dip. So you can actually see the retention ponds there. And that is pretty cool. And when you look at the map, so I guess it's not going to let us look at the map unless we dock this. If we dock this, see if we bring it in here and there we go. Let's see if it does any changes as we go through. No, there's nothing in the 3D map. 3D map doesn't reflect that. That doesn't reflect it, but there's the paths that were taken. So it's pretty fascinating. And you wonder if you look at the results, the identify results, what happens. Our lake we know is, if we click on it, that didn't work. There's a feature. Here. We had something going on before that I'm not seeing, but it does show meters. And down here, what is that? 509, 811. So each of these points has an elevation in meters. 1,000 meters, 1,000 meters, up here 1,800, 588. But some of these are lower. You go on the points. Pretty cool though. All right, let's see what else he has in store for us in the tutorial.
Now, I'm going to go in here real quick. I'm going to do some filtering on this. We can double click here. I'm actually going to right click on it. I'm going to right click on here and do filter. And now I can do classification equals ground. So let's just get all the ground points and we'll say okay. So this will give us that ground classification. I'm going to come over and change my layer styling to attribute by ramp. And I'm going to do it for Z values. And
so this is what we were
change my layer style to classification.
So maybe we don't need cloud compare. Let's see.
And double click here. I'm actually going to right click on it. I'm going to right click on here and do filter.
So right click it and do filter. All right, so let's go to the, I'm going to turn off Pasco because it's really huge. And just use my points because I have them. Right click and do filter. Where's filter? Right click, filter. All right. So what we were doing in cloud compare with this data is we went to classification and then we said equals 2 for ground, because that's what it says here, ground, and say okay, and that's exactly what we got before. And from the 3D layer you can see our ground is now devoid of trees. If we went to it and right click, it looks messy as hell here. If we went to this and right clicked on it and went to filter and said classification equals, and let me go back, clear. All right, and there it is. Go to classification, low vegetation, so we say classification equals 3. Maybe you have to do it several times. I don't know. And? Is there an and? Yes, and. We don't need. We just say 3 and, or no, not and. Let's see. No, and 4 and 5. What does that do? Nothing. Okay, stunks. Alright, sorry about that. That was a mess. What if we do filter 3 or 4 or 5? There we go. And now we only see the, oh, well, we do see other stuff. Maybe I have to do not. Occasionally it was 3 or 4 or 5. Is not equal to 9. What does that do? Nothing. Nothing. All right, well, I've got to figure out how to do this, but the filtering certainly worked for the ground. And I suppose it would work if I just wanted to do buildings. I could say classification equals 6. And say, okay, yeah, then we'll just get the buildings there. There they are. All the icky houses on the landscape. Here it just shows up like horrendously gray for some reason that I do not know. But in the 3D view, we do see all the key buildings right there as points. So the classification scheme thing is pretty cool. Classification equals high vegetation, that would be the big trees. Let's see. Ain't nothing. There ain't nothing but the real thing, baby. What about medium vegetation? Got no high vegetation, but maybe there's medium. No such thing. Oh, because there's unclassified. So the only way we do that, because it's been unclassified, is if we said to the filter, we'd have to say unclassified is 1, and then we're going to get the trees. And there they are. Now, I guess you can make a new layer out of this. Again, I don't know why it looks so awful there. It's classified. It takes a while to stream that stuff in. And I think I froze the machine. I did freeze the machine. Turning that layer, the streaming layer on. Not responding, and we just crashed the program. All right. Well, we learned
And
something.
now I can do classification equals ground. So let's just get all the ground points, and we'll say okay. So this will give us that ground classification. I'm going to come over and change my layer styling to attribute by ramp, and I'm going to do it for Z values, and we're going to change these minimums and maximums because these are way off. I wonder why we can't load it there. Anyway, we're going to change these because those are not for Z values. We're going to change this to about 1300 and about 3500. This is meters. And there you go. Now you can see that we get a little more differentiation in those ground points. You can see where there's a reservoir and there's a lot of water missing, or there's a lot of water where we're missing ground points. We can zoom in and see the elevations here. And this is going to take a minute to load, and then you'll see us get more detail as we get into this.
So I guess you can do this thing by Z. In my case, I had this crashing problem, but there it is, and I like to change the classification here to green for that. And what was he just doing? He was doing something with the Z. So let's take a look at that. He said
100 and about
attribute by ramp. So classification attribute Z, and don't do classification but do attribute by ramp. And then he was saying that it, well, this should actually work, but the Z-way is way messed up, so maybe we need to make it like 30 meters. And let's make this green. Oh no, that's not what I wanted to do. No. Well, make this, make it dark when it's low, and then it was this that I wanted to change, and then I want to go up here and say you are not going to be yellow, you're going to be green. How am I supposed to do that? Maybe I need a different gradient, color 2, and pick color 2, greenish, and then it's got to be continuous, it's got to be discrete now. So it does this thing where there's all these gradient stops, and sometimes you have to click on it and just hit delete, and get rid of all those stops. And if you do that, then you have the possibility of the ramp and going from low to high for attributes, intensity, classification. That's that interesting. So we can do RGB, extent only, classification, attribute, C. Attribute by ramp. So it did it again. It did it again. So yeah, click on one of these and hit delete. Get rid of it. Then we're looking at heights, in a sense. And if we said that the yellow color was a white, we'd sort of get a DEM is what we would get. So if we did like that and change this to like 30 meters, see, we get a DEM. And that's interesting because then if we go to our 3D view, then we see the darkness and the light, where the lakes appear depth dark, and then the higher stuff appears, although I don't know what that snow is like in there. So what did I do wrong? We're seeing colors showing through is what we're seeing in the height. It's a cool effect though, really, when you think about it. 1 and 30 is white. What if we did maximum 100? Now we're getting something more interesting. And then when we look at the 3D view, getting some interesting results there. I think it's backwards. I think it's flipped because I got a hole in the middle there. What if we did intervals going from dark to light? Live update, apply. Let's turn off the hybrid. It is backwards because the lakes are appearing white. Why is it backwards out in there? Intensity. Interpolation. Color ramp. Well, what if we flip this color ramp around and we say that you're going to be white and you're going to be dark? We didn't do that. Coloring it from white to dark. So the lake should be the lowest. If we're doing the, oh, we're doing intensity. I was supposed to do Z. Duh. All right, now, now we got to go back. So we got to flip this around. So this is going to be dark, and this is going to be light. Oops, what are you doing? Okay, I can bring it in the middle there. All right, now, so we're getting more like a DEM now. And bring this in. And again, we have things backwards. How is it possibly backwards? We said that the lower, if we're doing by Z, minimum is, oh, whatever the min is, Z. And if we change it around, and we start to get something more interesting. 30. Still backwards. This is freaking me out. 2. I mean, yeah, so that's the lakes. So why is this lake showing up as white? That's what's so bizarre. Sweet. Exact. Linear. Interesting. I need to play around with. So there's a lot you can play around with, I guess. And then you do it. Ah, there. When I do the triangles, it gets filled in. So that is the issue, is having the triangles. Which means now that I've done the triangles, I have to redo the view and get rid of this layer. And now do a 3D view. And it's kind of working and kind of not. That's somewhat promising, though. And it's nice to know that you can stream this. And the way, once again, that we streamed it is we had this pipeline URL, which I'm going to put into our Facebook group. So let me go there and say, use this pipeline for streaming Pasco County LiDAR data. Save the trouble. At JSON in there. And then, since I have that, I can come again into QGIS, and we can data source manager go to protocol, no, point cloud protocol, and then put that in, add it. Then we will get that data coming in. And then we can say by Z, and I just wait for it to come in. But attribute by ramp, there we go. And everything turns out to be weird. Let's see, by 40. And because it's not filled in, there's missing data. So the missing data is the stuff that's white. And I think that what we have to do is click out of range values and render as a surface. And it's still not perfect, but it shows that when we use this data, we can do it streaming. If I go to this map, it'll be the old map, because that's what I know. It comes in whatever's in there. All right, interesting. I'm not going to understand the min-max. Oh, because I did intensity. You don't want intensity, you want by Z. That's what we want. Yes, that's what we want. Because if we do that, then yes, the trees do appear higher. And they can be green, of course. There's nothing that keeps us from making them green. Except I didn't do it. Green would be, oh, that's the bottom. Coming from me, so it should be from ground. And then the color here should be green. But because there's all these continuous things which I have to erase, zip, get rid of all that. The gradient stops. Get rid of you, there we go. And now we start getting a better gradient. It starts to show up here, so the taller trees appear more green. All interesting. Very interesting. So what does he say after this? He says, we can classify
3,500, this is meters. And there you go. Now you can see that we get a little more differentiation in those ground points. You can see where there's a reservoir and there's a lot of water missing, or there's a lot of water where we're missing ground points. We can zoom in and see the elevations here. And this is going to take a minute to load, and then you'll see us get more detail as we get into this. So here it comes, loading those tiles in. I have a lot of things running, so it's being a little slower than usual, but you can see how we can just zoom in and zoom out, and this seamlessly adjusts to our resolution. Okay, now the other thing we can do is we can go to View, 3D Map Views, New 3D Map View, and you can see here that now we're going to be able to look at this in 3D, and it's going to take some time to load here. Anyway, you can see how we can easily stream this point cloud, and we haven't downloaded any data. That's perhaps the greatest thing of all this. We have not downloaded any data at all. I'm going to close this 3D map view. I'm going to zoom out here. Now let's go through, and we can actually make a digital elevation model from this. And it's super easy to do. So what we're going to do is go to the processing toolbox. We have these point clouds here.
This is what we want.
We have point cloud conversion, data management, and extraction. Because we can convert formats, export to rasters, using triangulation or otherwise. And we have other things, assigning projections, clipping, create a CLPC. We can just do all kinds of different things here. Okay, so we're going to export to a raster. And we have input layer, we want to export Z. We can choose a tile size. We're going to filter this down. So I'm going to do, let's do classification equals ground so that we're getting a digital terrain model or digital elevation model of the ground, and click OK. I am going to set the cropping extent, and I'm going to draw it on the map canvas. I'm going to do it for a relatively small area. So if it doesn't take too long to run, we'll just do it for an area like that. And then I'm going to copy this so I can use it again later. And I'm going to save this to a file. And
okay, so this is exactly what we wanted to do in class the other day. So here, if I just want to do the ground, and I have like Rosebud there, then I use my processing toolbox, which is here, and we make sure I'm doing the right procedure. He said, and I'm speeding him up to do
a model or digital elevation model of export to a raster. And
export to raster. All right, so coming in here, I go export to raster. There it is, point cloud conversion, export to raster. Using triangulation. Oh, that might be cool. Let's try that, even though he doesn't say to do that. So if I go like that, and I say I want to use the Pasco, Florida part that I have here, the resolution, advanced parameters, filter expression. So I do want to do classification, double click equals ground just to get my digital terrain model. And then cropping extent would be that from the map. We said to copy that so that we can use it again, X origin. Let's just run it. All right, let's see. Nothing shows up because it doesn't know the reference system. But it doesn't show up. Why? Why doesn't it show up? If we zoom, well, let me turn that off and try this again. If we were on this, did I not do so? I did something wrong. Let me come here and remove this layer. And actually go back to him for a second. What is it?
we have input layer, we want to export Z. We can choose a tile size. We're going to filter this down. So I'm going to do, let's do classification equals ground so that we're getting a digital terrain model or digital elevation model of the ground, and click OK. I am going to set the cropping extent, and I'm going to draw it on the map canvas. I'm going to do it for a relatively small area. So if it doesn't take too long to run, we'll just do it for an area like that. And then I'm going to copy this so I can use it again later. And I'm going to save this to a file. And I'm just going to save my downloads, and I'm going to call it btm.tif. I'm going to save it. My resolution is going to be 1 meter, and I will click run. This will take just a second here to complete. Okay, so we finished that. It took 12 minutes to complete, so a little bigger area than I wanted to do, but we can go take a look at it now. Just go ahead and close this. And we're going to notice, we're going to zoom in here, and you're going to see there are some holes in our model.
Wow, 12 minutes. Okay, so I'm going to come right into where Rosebud is only. Select it. I'm going to say export to raster. This time I'm not going to mess with anything else. And I'm going to tile size for primitive maps. Just make it 100. And then filter expression. We did want to do classification equals 2, so we're only using cropping extent. We can say use current map extent, and then we're going to save it to file. We're going to make it boundary maps, so put it in Pasco, call it point cloud to digital terrain model Rosebud, and then we're going to run it. It says it's complete. That's ridiculous. Shouldn't have taken that short a period of time. But it did. I don't know. Because it shouldn't be doing that. It's not showing up. Alright, so I don't know what to say. He got it working.
And that's just because of the method I used to interpolate. And there's these holes were probably areas where the point cloud was not dense enough for the interpolation method. And I'm going to turn this off. I'm going to show you how we can fix this. So instead of using this default export to raster, we can use the export to raster using triangulation. And so this will just create a triangulated irregular network that will interpolate between those points, and it will give us a continuous surface. So I'm going to use the same filter expression, which is classification equals 2. And I'm going to use the same cropping extent. So I'm going to just paste that in here. And I'm going to set an output file name, which I'm going to call DTM. We'll call it TIN for pin, and we will save that. And now I'm going to click run again, and you'll see the difference between these. And notice here we get this band 1 IDW, so use inverse distance weighting, and it probably had a distance threshold on it that we did not adjust or wasn't available.
So I'm not seeing any of that. And I'm going to try it with my own points rather than the... Oh, and that's not even showing up. There's the map. Wow. There's a whole map here. Let's zoom the layer. Alright, so something went desperately wrong here. There's that streaming stuff. This is my own data. And if I want to take that and make it into a GTM, maybe I'm using the wrong thing. Is he using point cloud to point cloud conversion? He's just using export to raster. He's not using point cloud conversion, and maybe that's where I'm going wrong. That's all I had was export to raster. Export. Database, GPS, layer tools, export mesh faces, export to raster is under point cloud conversion. Point cloud data management. Export, and then there's SAG, export raster layer. That's QGIS to web. Cartography database. That's all we have is export. And there's export to raster triangulation. We're using the now points, resolution, file filter expression. We can say I thought we had Z when we were doing it before. What did he have? Input layer, tile size, classifications 2. So
Modes, and I'm going to call it an area like that. And I'm going to save this to a file.
Attribute Z, export to raster, but here there's no attribute. Interesting. So triangulation doesn't have the attribute? Let's see. Export to raster, oh, it has the attribute, which was Z. So what if we don't filter it? What if we just do it and we say cropping and we pick use current extent or draw? Try. And then exported file. And then can rewrite that and run it. Now it's doing something. Okay. I'm not even sure what I did differently. But GDAL error. Permission denied. Alright, let's change this. Let's just give it a new name. Let's go point cloud trial. Let's run this. Files are not supported. All right, can't do that. So go save to file and then call it point. Oh, it did there. Point cloud trial 2 and say run. And that time there was no problem. And we have a raster point cloud. Not that one, that's nothing. This can be removed. But this one here, trial 2, is a DEM. But that has all the information. So now we want to try this idea of doing classification on it. So if I take this and I run this again, export under point cloud, export to raster, and I use the Z value, and I use a filter expression and say classification, make it classifications ground, and then I use the same cropping extent that I copied before, and then I save it to file point cloud DTM ground. And it didn't like that. False argument filter needs a value and none is provided. What was none provided? Oh, classification equals 2. Duh. Okay, classification equals 2. And now rerun it. And getting exciting. Okay, so this is now got the ground to turn everything else off. So there's the ground. It's missing some data. And if we look at the 3D view, then we'll just turn that off. Look at the 3D map view, and we see just the ground. And the ground is flat, as well it should be. All right, so this is successfully working. If I can get this to close up, why can't I do that? All right, and then if we add onto there the point cloud trial 2, that has the not what it needs. Oh, it crashed the program. Of course it crashed the program. But we're getting somewhere for sure.
And I'm just going to save my downloads, and I'm going to call it. Okay, so we finished. Fix this. So interpolate between those points, and it will give us a continuous surface. So I'm going to use the same filter expression, which is.
I'm trying to do the triangulation now. If I can get this thing to load again.
Classification equals 2. And I'm going to use the same cropping extent. So I'm going to just paste that in here. And I'm going to set an output file name, which I'm going to call DTM. We'll call it TIN for tin. And we will save that. And now I'm going to click run again, and you'll see the difference between these. And notice here we get this band 1 IDW, so we used inverse distance weighting, and it probably had a distance threshold on it that we did not adjust or wasn't available to us to adjust. And so here we're going to do that. It's probably based on, usually it's based on the resolution. Let's go ahead and click run. And once again, this is probably going to take 12 minutes or more. So we'll just pause this and let it go. Okay, so that completed. That one took half an hour to run. So I showed it in a little small area. We can take a look at these results now. So now you can see.
But I did save it. So if I now, I can turn off Google Hybrid, I can turn off points for a second, and I can add in here my, wherever I saved it, where did I save it? B and D. It's in favorites actually. And I have my exports. I think I exported it somewhere. In Pasco. Where's Pasco? Old maps, tutorials, spreadsheets. Coordinates. I should have marked all of that too. Maps, Morocco, Spain. Terms for tutorials. Somewhere it's in here. Buildings and polygons. And we'll look under here and look at under here. Boundary maps, presentations, areas, climate, trail, Pasco County Cloud, and here somewhere we have the Pasco Cloud DTM ground that we brought in. There it is. And there is the Rosebud one, which fits right over it. And so that has the trees, and if we save this, so now that we have those, let's look at the view, 3D map views. And it's not using the DEM. So the point cloud showed up. Here we're doing a DEM, and we have to tell it the elevation we're going to use is the, if we use the ground or we use the point cloud. If we use the point cloud, then you get this kind of unevenness, because the trees cause this bumpiness, because the resolution is really tile resolution. What happens if we do 1 pixel, I wonder? A whole lot of nothing. If we do 5, yeah, okay. So using the digital elevation is not the best way to do this clearly. If I do the point cloud for the ground, then you're going to see that is, oh wow, that's really messed up. Fascinating. Because there's a lot of data missing. So I guess that's what he was trying to say about this, because there's all this data missing. So the next thing he was going to do is he was going to take all this information from here, and he was saying that you should do it as a triangulation. So under processing toolbox, when you get export to, and use the point cloud export using triangulation, if we use the import layer of points, instead of, there's no Z because it's going to triangulate, I guess. So now filter expression, we can do ground, I guess, again. So classification equals 2. And then he's going to export this to a file. It's going to be called point cloud ground triangulate. Now, try to run that. Oh, then the extent is going to be, I'll draw the map canvas, and we'll just do the same piece here. And then we will say run. And it did it. And apparently it triangulated it. So if we now turn the triangulated one into a 3D view, these massive gaps in it. Why is that? Maybe we have to make a new view and get rid of the old map. It is okay, but it's not using digital elevation. It's flat. So if we do the DEM and we say point cloud ground triangulate and apply it, then it does have some information. If we turn on the Google Hybrid and we move this underneath, then when we look at the map, we have some idea of that, which would only really work if you were in the mountains or something. The vertical scale can be brought up 3 times what it is, and still we're not seeing it very detailed, of course, because it's not made for that. The point cloud data was much higher resolution, and I don't think skirt height offset, there's nothing that I would understand what to do with the tile resolution. I mean, if we bring it down to 4 and apply it, doesn't change things much. Maybe that was part of the export, like when we were coming from this point cloud and saving it, because as you can see, if I have this on and I go to 3D map views and I turn off DEM and just make it flat terrain and turn off Google Hybrid, that has the trees in it, and that does not rely on a DEM. If we did a DEM based on the whole thing, so if we took this points and once again we went to export to raster using triangulation from points, resolution of the density raster, filter expression none, and if we then save this as point cloud full Pasco, and we said that we wanted to use that same cropping extent, so use that, and then run. Then we get a raster, and that raster might indeed work. Let's see, if we go to 3D map views and turn it on, we're still looking at this point cloud. We want to look at, there we go, but we want to use the DEM. So we want to say we don't want a flat terrain, we want a DEM in which the point cloud full Pasco is what we're using. Our vertical scale should be 1. And then, yeah, Isn't that interesting? And it's cool, but it's weird. If we turn on the Google Hybrid and look at it, we'd have to bring the Google Hybrid up above, or at least bring this down underneath to distort the landscape. And then we start to see some distortion like that. But we're not really, we're getting, this is as though it was the landscape rather than the trees. Now, what would be interesting at this point is to wonder if one can export this as a 3D. We won't know. And then see if we can go into Blender. What can we do in Blender with this? Well, let's see. Oh, did I just run out of space? Am I still recording? I am recording. I think. Yeah. Right. So if we go to GIS here and we say to import, and we import the georeferenced raster, and we bring in, let's see if we've got something here, terrain. What day is this? 223, that's it. So that's the one that that's a JPEG though. So that didn't do anything. It was modified just a second ago. And I can bring it in, but it doesn't open that raster because it's not a raster. So let's import again. Import a raster. And let's go to Pasco. And let's say Pasco full. Pasco, this one here. There's nothing there. And put ground triangulate. If we take this modifier and add to it a generate, what am I putting on here? Form or displacement modifier, and make the strength big. It's not changing anything. Put the texture. We're not getting much of anything for that. We bring in web geodata. No. So it's there, but it's not showing up. We put a texture on it and bring in to the surface, add a shade of base color. It would say would be an image texture. Then if we bring in these are all different. That doesn't do anything. It's the wrong one anyway. add shapefile exports terrain. This is the one I brought in today. So there's that terrain, and it lines up, of course. That's what was exported. And then when we go to the displacement modifier, there's just not a lot of curvature in there. And it didn't really bring in much of anything. Point cloud full Pasco add modifier. And once again go and add to this point cloud. Image texture and open that. Which means I can turn off this one. Let's see if I can do a displacement on this. I don't think it has any. Yeah, there's not a lot of information in there to displace by. Texture. Vertex group, local coordinates. So, not a lot happening here with that for exporting out. If we go to web geodata and we go to base map and we zoom in, we should really find a go-to and then say spread continue. And say okay. It's not going to find it. So we need to go to Pasco, Orlando Lakes, Florida. See if that, yeah, brings us in. And I mean, if we get more specific, if it's been geo-referenced, you can go 22843 Orlando Lakes, Florida. Let's see what that does. There it is. All right. And if we set the extent on that, question is, where is our other point cloud? Let me hit. It's there, but it's not anywhere near. So it's supposed to be geo-referenced. And is it? No, it ended up in a different part of the world, even though it's supposed to be geo-referenced. So when you import a geo-referenced raster, oh, it did come in on top. Okay, so it does come in. So maybe I need to get rid of this one. Get rid of this one. This one does come in over that. Oh, something wrong. I shouldn't have done that. Go Control Z. Where did it go? That is. So we don't want, this one. Where's the one we just brought in? Yeah. Yeah, it's not coming in, it's not lining up, which is strange, because it's supposed to line up. Because in this case, you can go to bring in your elevation from the SRTM at 30 meters, and that's supposed to cause the wrinkling that you want. Please define the query extent in the top view. There it is. Let's come in. So that's that. But the point cloud for Pasco ain't coming in. Just isn't in that purview. So there's like this, all this stuff going on here. It's got nothing to do with the other extent that we have. And isn't it weird because it's way over and not related to this at all. I mean, it should be down here, and it's not. And maybe that's because this came in at the center of the screen. Ah, there it is. Look at that. Okay, so there's our thing. And now we can bring it in. So the problem was really that when we brought in this, we brought it in the center of the world, and we brought in the other. It didn't know where to go because it was georeferenced. It was georeferenced, and the other one came in the center of the world. So maybe what we do is we go to this one here, and then, or this one here, which both came in georeferenced in the right place, or did they? Let's get rid of this one now. In fact, let's get rid of them all. Okay, so let's go here, and let's first bring in a base map. Center to existing objects. Okay, so what we'll do is we'll go in and we'll bring in our geotiff, which would be the point cloud ground triangulate, and we'll give it a texture which is from here. Right, so we have that. And then when we want to bring in the web geodata base map, we do center to existing objects. And then say OK. And ooh, look at that. That's crazy. Center to existing objects. That puts us in the middle of the desert. Alright. What if I said, I don't know what I'm doing? That would be cool. But I don't. I don't know what I'm doing. Center to existing objects doesn't work. We're in a different projection. And it's always this projection thing that messes us up. So don't save that. But we did learn a few things about point clouds in QGIS, and that was interesting. And the last thing is just to watch this guy finish his
the our 10 DEM from triangulation. And let me turn this one underneath off. just so you can see there's no other layers turned on. You can see there are no holes there. And so the interpolation method using the triangulation approach gives us smoother DEM without the holes when we do the triangulation interpolation, but it does take longer to accomplish. Okay, so that's just an example of how you can use these streamable point cloud formats. So like I said, this is an EPT. You can also use COPC files, cloud optimized point clouds. To do this, this is not something you can currently do with ArcGIS Pro. In fact, Arc Pro only allows you to use LAS files. So you can't even load in LAZ files, which seems pretty rudimentary to me. So QGIS has a lot of cool stuff coming with this. They've done a lot of cool stuff with this, and I expect more is coming. I want to point out one last thing. If you click on the export to raster, I forgot to mention this. It gives you a little bit of information about the algorithm here. So it doesn't give us a whole lot. You can see that it has IEW, so we know it's inverse distance weighted, but just giving you a little more information on that algorithm. So I hope you found this useful. Stick around for the next video. I'm going to show you how you can use these data to make a canopy height model in the next video, and so we'll go over that shortly. So thanks for watching, and
well, that'll be cool. The canopy height. That'll be our next thing as well. All right, that's our blunder through for tonight.